Electrochemistry, like any other topic of chemistry, is based on the concept. So if you understand the concept nicely, I don't think you should be having any problems in understanding electrochemistry. Electro means it's something got to do with electrical energy, and chemistry is all about chemical reactions. So by and large electrochemistry में क्या हो सकता है? We can have only two types of reactions. One can be electrical energy that can be converted to chemical energy, or your chemical energy can get converted to electrical energy. बस हो गया chapter. I repeat, what we are going to take up is the topic of electrochemistry now. Seems lengthy, but is nothing but it is only the branch of science that deals with some form of electrical energy getting converted to chemical energy and chemical energy getting converted to electrical energy. Clear? Understood? So, say when I talk about the electrical energy to be converted to chemical energy, I generally talk about the electrolytic cells. Alright, electrical energy being converted into chemical energy, then I am talking about, what did I say? Electrolytic cells, because this is very important for you to understand the base. Alright, electrochemistry is that branch of science that deals with the study of electrical energy, chemical energy. होगा क्या आपस में interchange ही हो सकते हैं, because energy can change from one form to another. So the electrical energy can get converted to chemical energy and the chemical can get converted to electrical energy. Now just understand, if I am talking about the conversion of electrical energy, means I am passing current and then a chemical reaction is happening. So electrolytic cells are useful for those systems where the reaction is non-spontaneous, but if we pass current through it, maybe the reaction becomes spontaneous. ये चीज़ समझ में आई? Because for any reaction to occur, I know that the reaction has to be spontaneous, and for that delta G should be negative. Alright, this you all remember, that the free energy change should be negative. So here also again, if we want any change or any cell reaction to occur, our delta G should be negative. ये चीज़ तो clear है? Now we will talk about it in details later, but understand there are generally by and large two types of cells that we talk about. One is the electrolytic cells and the other are the electrochemical cells. In electrochemical cells it is the other way around. In electrochemical cells we utilize the chemical energy of spontaneous reaction to generate current. So what we have is the chemical energy is converted to electrical energy there. When the chemical energy is converted to electrical energy, then we call them electrochemical cells. Electrochemical cells का एक type है, you have galvanic cells. You have galvanic cells to be a part of the electrochemical cells. तो इसमें confusion नहीं रखना. Electrochemical cells are those which convert the chemical energy. तो इसका मतलब कोई reaction spontaneous है, उसकी energy को use करके we are producing current. Alright, so galvanic cells are also known as, so it is better that you remember the names here itself, are also known as chemical cells, or they are known as voltaic cells or galvanic redox cells. These are the other names. So you come across any of these names and remember that we are talking about the electrochemical cells, right? Two types of cells that we have talked about, very simple. Electrolytic means that we are using the electrical energy and converting it to the chemical energy, because the current that is passed is used to carry out a chemical reaction. In electrochemical cells, the spontaneity of the reactions, because there are spontaneous का मतलब क्या है, जो reactions अगर आपने reactant ले लिया A and B, आपस में दोनों को रखा, they'll spontaneously react, अपने आप से ही they'll carry on the reaction to form an AB or a product. So that such spontaneous reactions energy can be used to convert or to generate current, which is known as electrical energy, and such cells are known as electrochemical cells. And the other names of electrochemical cells that you will come across will be galvanic cells, or you can have voltaic cells, or you can have redox cells. Alright, then another thing that we can talk of is Generally, if I talk about chemical cells, I can relate it to two things. Chemical cells, and you can also have concentration cells. In chemical cells, you have the example, the best example that is given in all your books is also that of Daniell cell. Daniell cell is nothing but Zn, ZnSO4. Then you have, this is the general representation of the cell, where you have the metal representation first, followed by its aqueous media, followed by a salt bridge. Then you have, it is made of copper sulfate and you have copper. Okay. Generally, cathode is drawn on the right and anode is drawn on the left. Okay. Certain more things, let me just remind you of certain other things. We have already done redox in 11th. I hope you remember that there are, like generally in the construction of the cells, you have electrodes. Electrodes are certain metallic conductors which are dipped into the solution to construct a cell. ठीक है, तो अगर हम electrodes की बात करें, there are two, and cathode is where cations are attracted. So generally now I am not talking about positive or negative charge, but I told you something that at anode what happens? Oxidation always occurs at anode. So that means oxidation means that if I am talking about anode, I have drawn to the left, I told you. So here I will be showing it to you as plus 2 electrons, and for the cathode the reaction will be Cu2 plus becoming Cu, because here you know Cu is in plus 2 oxidation state. So you have Cu2 plus 2 electrons is giving Cu. Just to remind you that oxidation means release of electrons, which will only happen at anode, and reduction means acceptance of or gain of electrons, which will happen primarily at cathode. When I talk about concentration cells, the concentration cells are generally that when you have a metallic electrode and the metal present in some concentration, say C1, and then you have metal to be present in some concentration C2 followed by an M. The general representation, see, if you can see the construction of the cells, the reactions are something that you can actually think about it on your own. The reaction at anode will be M giving M plus electrons, right? And the reaction at cathode will be M plus electron giving M. So you can see that if you have the construction of the cell before you, in many of the questions you will be provided this total cell. This represents your cell, alright. So you can easily write down the reaction as M giving M plus C1 plus electron, and the other reaction will be MC2 plus electron is giving you M. Now here there will be no net chemical change unless and until there is a difference in the concentrations. And you know, if the concentration of one is higher, where will the metal flow from? From a higher concentration to a lower concentration. So this you have to make a note of, that if I say C2 is greater than C1, then in that case there will be a net change, as in the metal will be moving from C2 to C1. And there will be a net change in energy. So you can talk about concentration cells when you are given the concentrations of the two metallic ions in this fashion. Just go through what I have put on the board. Daniell cell, yes, it is a type of electrochemical cell only. It is a galvanic cell. Here also, in both the cases, what we are doing is concentration cells may primarily we are just talking about that if we have two solutions, then in that case there will be a change if there is a change in concentration depending upon whichever cell you are talking about. Unless and until there is a change in the concentration, there will be no flow of electrons. So if there is a change, flow of electrons will only be when there is a change in concentrations. It can exist in both the types. conclusions as such. So presently I am just talking about, you are just checking out the basic definition of electrolytic, electrochemical. Otherwise if we go into the positive and the negative, there will be a lot of confusion. So just go through it once, that electrolytic cells and electrochemical cells, the basic difference should absolutely be clear to you. And all you have to remember in case of Daniell cell is, just remember it comprises of zinc and copper. The solution, the aqueous solution of both is like taken as zinc sulfate and copper sulfate, and then that is how we represent our cell. This, for the cell representation, I will just quickly talk about it. The characteristic of the Daniell cell is that in case of Daniell cell, the oxidation and reduction happens simultaneously. Okay, you know what is oxidation? Release of electrons and gain of electrons. It will just happen simultaneously at the same time. And how it is done? Say supposedly you have a zinc electrode which is dipped in zinc sulfate solution, alright, and then you have a copper electrode which is dipped in copper sulfate solution. So here you have, say, ZnSO4, you have CuSO4, you have Cu here, you have Zn here. So you have to remember zinc and zinc sulfate and copper sulfate will actually constitute, but the cell is still not complete because there is no transfer of the ions here. So in that case, what will you do? You will actually connect it using a salt bridge. So the main purpose of the salt bridge is to connect the two cells, and it makes the cell complete. And it is a useful thing for making your ions get transferred from one half cell to the other half cell. Generally, the liquid or the aqueous solution which is used in salt bridge is that of KCl. This is like a general solution which is used in salt bridge. So we will quickly look into it. So here, this is like the Daniell cell, and you remember the functions of salt bridge which are very general. A salt bridge, as the name suggests, is a bridge between the two half cells. It makes your cell complete and accomplishes the movement of ions from one half cell to the other half cell, right? Then, yes. The ions are neutralized, only then the cell will be complete. So there is a complete compensation of the loss and gain of electrons because of salt bridge. Because if you talk about half cell reaction, you know that you have seen half cell reaction as Zn giving Zn2 plus 2 electrons. So in this, 2 electrons are lost into the solution, and then at the other point these 2 electrons need to be carried to the other side. Why? Because now your Cu2 plus would require 2 electrons from the zinc side, from the zinc half cell. So this electron compensation will not be made unless and until you join it using a salt bridge. So that is why you talk about the neutralization here. It is simply, yes, it transfers actually it in the form of the ions or electrons. So you call them ions only in aqueous media. I'll just talk about the difference between the electronic and electrolytic conductors, and probably it gets more clear to you. You all know the difference between conductors and insulators. Conductors are those which actually are helpful in conducting of say the current or ions. Insulators are those which do not allow any kind of current to pass through. So when I talk about, there can be two conductors primarily. There can be two types of lytic conductors, alright. There are two conductors that we can primarily talk about. One is the electronic conductors and the other is the electrolytic. In electronic conductors, which are also the metallic conductors, the current is passed mainly because of the flow of electrons. Please make it a point to know that here the charge is actually getting transferred because of the flow of electrons. That is what is your metallic conductors. And in electrolytic, the flow of electricity, in this case the flow of electricity is mainly due to the flow of ions, is mainly due to flow of ions. Whereas in case of electronic conductors, it is mainly due to the flow of electrons. This you have to remember. In this, the flow takes place without any deposition or decomposition of any substance, whereas in case of electrolytic conductors, there is the flow of say ions is always accompanied by deposition or decomposition of some substance. Alright, then another thing is, concentrate on the metallic conductors or electronic conductors where the flow is because of the electrons. If I increase the temperature, what will happen? If I increase the temperature, there will be the metallic or the metal ions or metals will start vibrating about their position. If they will vibrate, they will obstruct the flow of current or the flow of electrons. So as a result of which if there is more resistance offered to the flow of electrons, the electronic conductance will decrease. ये चीज समझ में आई? I repeat it again. In case it is dependent on temperature, both are dependent on temperature. But here if we increase the temperature, if temperature increases, then the electronic conductance will decrease. It will decrease because your metals will vibrate about its mean position, and so they will resist the flow of currents. Whereas in this case, it is primarily due to flow of ions. And एक चीज याद रखना, ions exist only in solutions. You cannot have ions here in your hand. Ions can exist only in solution. The best example that I always take is that of NaCl. Very nice. So when we talk of NaCl, you know that if you hold NaCl in your hand, you will not feel any current. Even otherwise, not even in salt solution, unless and until you pass some charge in it, because the ions increases. So what happens when you increase the temperature? The dissociation will further increase for any of the electrolytic conductors, and if dissociation increases, the conductance will increase with temperature. Is that thing clear to everyone? So what did I say? Or in general, you can note down that conduction decreases here with temperature, conduction decreases with temperature, and the electrolytic conductance increases with temperature. Okay. So electronic conductors means that I am talking about electronic or metallic conductors. I am talking about electronic or metallic conductors. Then there are certain terms that you should be familiar with. Electrolyte, what are electrodes, and then finally what is an electrode potential. I will just acquaint you with these words: electrolytic potential. See, electrolyte is generally a substance which, when present in any form, in solution or otherwise, will generally help in transfer of ions. I repeat it in a better language. An electrolyte is defined as a substance that, when present in solution or in molten state, will conduct the electric current. Clear? Electrolyte is generally a solution which will help in passing of the electric current, or it will help in the movement of the charges from one place. And then you talk about the electrodes. Electrodes are nothing but they are electronic conductors. What are electrodes? Electrodes are nothing but they are the metallic or the electronic conductors. So I don't think a better definition than that exists. But what is written here is that they are the ones which are in contact with the electrolytic conductor. I'll just explain. See, just understand here, if I am talking about, say, any two electrodes which are dipped in a common solution of, say, H2SO4, alright. I am taking one single container and I have dipped two electrodes. These electrodes are made of some metal. So these are the metallic conductors, or these are known as the electronic conductors. Then I talk about the electrolyte. Electrolyte is that substance which in solution or in molten state helps in the passing of the charges or conducts the electricity or current. conducts the current basically in solution form. Then what is this electrolytic potential or electrode potential? Generally you talk of the electrode potential only, so let me not confuse you. The electrode potential is the potential difference that gets developed between your electronic conductor and the electrolytic conductor. Electrolytic conductor means you know that there will be some charges or ions which will be given out from one of the electrodes and it will be taken up by the other electrode. So whatever potential difference develops between the electronic conductors and the electrolytic conductors is what is known as electrode potential. Do you understand that? So electrolyte here in this case can be considered to be electrolytic conductor because it is only helping in the movement of electricity because of flow of ions. So whatever potential difference, देखो अगर if this is causing some flow of electricity, it will be related to some EMF, right? If this is passing or it is actually acting as a flow, I mean helping for the flow of electricity, then this is also associated with some EMF. The difference between the two potentials is what is known as the electrode potential. You understand? This is only for you to understand qualitatively, otherwise the formula and the chapter is very easy vis-a-vis your exams. No, it will be considered as one then. Say you have the plates, the potential difference which is there between the potentials of the two, the electronic conductors and that is why when we talk about the E naught of the cell, it is always E cathode minus, so uska potential difference minus the other potential difference will give you the total potential difference of the cell. Yes. It is the difference in the electronic, because cathode is nothing but your electronic conductor and electrolytic conductor is that. So ये सिर्फ समझने के लिए है कि what is actually potential difference or the electrode potential. The electrode potential that I am talking here is nothing but it is the potential difference which gets set up when there is flow of electricity and you check up the potential difference between the electronic conductors and the electrolytic conductors. ये चीज़ समझ में आ गई, ये सिर्फ समझने के लिए, इसके बाद तो सिंपल फॉर्मूला है. ओके, देन यू हैव अ सिंपल फॉर्मूला दैट इज व्हाट समबडी वाज आस्किंग. सो हाउ डू यू चेक अप द पोटेंशियल डिफरेंस बिटवीन द टू? से द पोटेंशियल डिफरेंस से बिटवीन, से इफ वन इज कैथोड and the other is anode, in electrolytic cells your cathode is negative and your anode is positive, and I told you how to remember that. Cathode attracts your cations and cations positively charged होते हैं तो cathode का charge will be negative, and anodes attract anions which are positively charged, which are negatively charged, so anode will be positively charged. Okay, so and now if I talk about a general thing which is that of E naught cell, this is the potential difference for any cell, that will always be the E cathode minus E anode, and this is what is the potential, electrode potential difference that I did talk about. And when you talk about between your right and left half of the reaction, then the difference in the right and left electrode potentials, that is your electrode potential for the cell. Otherwise the electrode potentials that earlier I just explained it to you was simply the potential difference between the electronic and electrolytic conductors. And when you take each of the half cells and compare them, then in that case your EMF is known as your the electrode potential of the cell. Now there are certain things here. This is known as EMF. ठीक है? What is EMF? Electromotive force. You all have studied that. Force के units क्या होते हैं? Newton. पर EMF के units क्या होते हैं? So why is it called EMF? Please remember, it is only a misnomer. So it is not generally a force. It is the name that is provided because that's the force which tracks the ions into action and they move and then a voltage is generated. Okay, then another important equation is your Nernst equation. Factors, you can also note down the factors that affect the electrode potential. First is the nature of electrode, that decides nature of electrode. Then the second is concentration of ions in solution, concentrations of ion in solution, and then temperature also is an important factor. Temperature is also an important factor. This E naught cell can also be written as E naught cell is equal to E right minus E left, because in the construction of the cell, what did we see? We had seen in the construction of the cell, say if we have a metal, we generally write it as metal electrode. Whatever electrode you are taking for your anode is written first. You know that at anode what happens? There is oxidation. So generally it will be Mn plus. If you know the concentration, then the concentration is written in the brackets, and then the medium, whether it is liquid or aqueous medium, whatever it is written here. Then you know that the two half cells are connected by a salt bridge. So this is the representation of the salt bridge, and then if this is representing your anode part, then the other will be your cathode part. So for the cathode, you know what happens at cathode? Reduction happens. Reduction means that your Mn plus will, the general state is generally written here, and you have, because Mn plus will now be reduced to M. Now in certain cases what you have is, you are given the solution, say zinc sulfate or copper sulfate. You know that zinc sulfate is nothing but representing your Zn2 plus ions. Copper sulfate is given, that is represent your Cu2 plus. Another thing is, sometimes you have, instead of the metal, you have the platinum electrodes. So there you will find, instead of M, you will find that it is written as Pt, and then slash you will have your ions. And sometimes what happens, you do not use a salt bridge, but rather you use an electrolytic solution. So in those cases you find that the representation of the cell becomes M going from M to Mn plus. This is your anode part. Then you have, say if the electrolytic medium is say H2SO4 along with its concentration, whatever the concentration is, because that now acts as a bridge between the two parts. So instead of the salt bridge, then it is actually separated only by a single slash and a single slash, because I am filling it in this part. Same solution at times. So this is also another representation, and then the other half of the cell is shown. So this is just another representation. We look into more representation once you can digest this much. ठीक है? Okay, then there is a general way also of finding out the E cell. Say Nernst gave an expression to express the electrode potential. Nernst is the name of the scientist who gave an expression to express the electrode potential. For any reaction, say this is the reduced state, and say you have Mn plus, then this is the oxidized state, plus you will have N electrons. So in that case Nernst gave the equation as, you can have the E cell is equal to E naught cell minus RT by NF into ln of activity of the oxidized state upon the activity of the reduced state. That is defined by the definition when we start talking about the specific conductance, molar conductivity and all. Right now we are not referring to the distance, we are just seeing the factors which decide the general EMF of the cell. We are not relating it to any other thing. Yes, because then the potential difference will accordingly depend upon that. There are many other factors. You talk about conductance, you talk about conductivity, you talk about, and how they are dependent upon temperatures, like mainly the prime factor that we will just talk about. Alright. reduced state and the oxidized state. Okay, so Nernst gave this equation of, it is generally written as E cell is equal to E naught cell minus RT upon NF, where F is the Faraday's constant, N is the number of electrons which are furnished in any reaction, R is your universal gas constant, and T is the temperature. If no temperature is provided to you, you will take it at the room temperature, which is 25 degrees Celsius or 298 Kelvin. So here the temperature is generally substituted in Kelvin, and then you have log of, you can generally write it as concentration of the anodic part upon the concentration of the okay. So this you can remember. We have just not talked about any other thing in this particular chapter till now. We started by talking about electrochemistry. What is electrochemistry? It is the branch of science that deals with electrical energy and chemical energy. Now you fill in the blanks and tell me very simple questions that will not be put up for your JEE, but you should be knowing what are those cells called which convert electrical energy to chemical energy. Electrolytic cells. What are those cells called which convert chemical energy to electrical energy? Electrochemical cells. A type of them are galvanic cells. Can you just tell me the constitution of Daniell cells, the two metals which are involved? Zinc and copper. Zinc forms the anode and copper forms the cathode. Rest of the reactions you can write on your own, right? Then we did talk about in Daniell cells, the other names of the galvanic cells that can be provided are voltaic cells, redox cells, or you can call them chemical cells also, because they are types of electrochemical cells only. Then we talked of the, say if you are talking about the chemical cells, you can also talk about the concentration cells, in which there will be a flow of ions only if there is a difference in the concentrations. If there is a difference in the concentrations. Then what is special about the Daniell cells? That the reduction and the oxidation reactions are occurring simultaneously. Oxidation means loss of electrons. Oxidation always occurs at which electrode? Anode. Please remember, oxidation always occurs at anode. Then after that we talked about the general construction of the cell, in which you can either have an electronic conductor and you have an electronic conductor and an electrolytic conductor. In electronic conductor, the flow of electricity is primarily because of flow of electrons, because they are metallic conductors. In metals, there is flow of electrons only. When you talk about electrolytic conductors, then you are talking about the flow of ions. So flow of electricity is due to the flow of ions. Alright, then electrolyte is that solution or some substance in a molten state which helps in the flow of ions, and that is something which is responsible for completing your cell also. The purpose of using a salt bridge is very elementary, so we are just doing the basic part of it. Salt bridge connects the two half cells and completes your cell reaction. It also helps in the complete neutralization, or you can say it helps in the flow of the electrons from one half cell to the other, and that is what is the bridge basically. See, that's what I told you, that if you talk about any cell where you have connection like this, alright, you know that these are your metallic conductors which will only have flow of electricity due to flow of electrons. Now here when you are talking about Zn giving Zn2 plus electrons, there may also be a need that the ions need to flow to the other half. Here in this case, these ions are the ones which are associated with your Zn2 plus only. So that is why you need a salt bridge for the flow of the ions to be possible. Otherwise your electrons can only be taken up if it is feasible, but it will not take up the electrons. The electrons can only be taken up by this half, because here you have Cu2 plus. Ab un do Cu2, नाउ Cu2 प्लस रिक्वायर्स 2 इलेक्ट्रॉन्स. अब इसको इलेक्ट्रॉन्स देने के लिए ये तो लेगा नहीं, ठीक है, बिकॉज इट डज नॉट हैव दैट प्रॉपर्टी. ये तो सिर्फ इट कैन गिव इलेक्ट्रॉन्स बिकॉज दिस इज योर एनोड, right? So here it will only give the electrons. If this can only give the electrons, तो ये यहाँ से तो पास होने का मतलब ही नहीं है. So you need something to transfer the electrons. Understood? So in order to transfer those electrons, you need a salt bridge. So you basically talk of the flow of ions because it is like comprising of some solution. Generally it is either KCl or AgAgCl. वो ट्रैवल होकर क्यों जाएंगे? ये आपका एनोड चेम्बर है, ऑलराइट, एनोडिक चेम्बर से यू हैव अ पॉजिटिव चार्ज हियर. सो योर मेटल कैन ओनली गिव Mn plus n electrons here, because at anode what will happen? Oxidation. If oxidation will happen, it can only give electrons. Why will it take back the electrons? It is against its property. And at cathode you have only Mn plus existing in solution. Say it be of the same metal or some other metal. So here you have Mn plus existing which needs electrons. अब ये electrons जो एनोड ने ऑक्सीडेशन में दे दिए वो यहाँ तक कैसे ट्रांसफर होंगे? आप सब सोच रहे हो कि शायद अगर यहाँ पे ये कनेक्टेड है तो फिर ये यहाँ से चला जाएगा, बट एनोड हैज द प्रॉपर्टी ऑफ giving electrons or losing electrons. If it has lost electrons, why will it take back? It will not take back. And now this needs electrons to get reduced. Now in order to have those 2 electrons, you need a 2, 3, whatever, n number of electrons. It will be connected using a salt bridge. तभी तो वो ले पाएगा, otherwise वो लेगा ही नहीं. Cathode becomes, that is why I changed my CuN copper to MnM. I changed. Otherwise it is the opposite. In electrolytic cells, we are talking about electrolytic cells presently. So anode is positive and cathode is negative. The sign convention changes in case of electrochemical cells. Please take a note of that. But still anode is associated with loss of electrons and cathode is associated with gain of electrons. Understand just that part. So that is why I did not go into it, otherwise you would have got confused with the rest of the equations. Just remember that for an electrolytic cells, cathode which attracts cations will be negatively charged because cations are positive, and anode which attracts anions which are negatively charged, so anode will be positively charged. So cathode matlab negatively charged electrode, cathode means negatively charged electrode, बाकी तो याद ही रहेगा फिर. There are several properties related to the transport number of the ions that we will talk of as we move ahead with conductance. So that is an appropriate level for KCl, and sometimes you just need not use KCl salt bridge always, depending upon what you have in your solutions on either side, not just the thing that you are talking about, but we can use even other types of salt bridges. You can even have it for AgCl, you can even have it for some ion which is reversible to 1/2 cell, but that's off the track. Now coming back, then after talking about the electrodes, we talked about the, after talking about the electrodes, we did talk about the electrode potential. Electrode potential is nothing but it's the potential difference that develops between the electronic conductor and the electrolytic conduction part. So, and the difference between the two half cells gives you the E0 cell of the, gives you the electrode potential or potential difference of the cell in totality. So that is what is represented as the EMF of the cell. So E0 cell is equal to E cathode minus E anode or E right minus E left. This is just a property of the cell as it is provided to you. But when you actually start up with any reaction, the E0 of the cell was already a property of the cell. That minus RT by NF, ln of concentration of anode upon cathode will give you the total E cell of that particular cell reaction to occur. ये समझ में आया? That is what is going to give you the E cell of the reaction. Now here you just have to take care of certain other formulae which are involved. say if I am talking about any cell reaction, सबसे easy way out है इसको याद रखने का, that if you put a minus here, you won't remember whether anode comes on the top or cathode comes on the top. Sometimes some students get confused because of that. For that you can actually remember that if you have any reaction AA plus BB giving CC plus DD, the small alphabets are representing the stoichiometric coefficients. Now here this can be simply log of concentration is C to the power C, D to the power D upon, I am just writing this part again, upon A to the power A and B to the power, which can also sometimes be represented as your Q. If the reaction is in equilibrium, then you call it the K, KCK. Otherwise, now that you have talked of Kc and Kp, let me just tell you that all these are related to the activities only. All these are related to the activities. Activity is actually equal to the activity coefficient and into the concentration. So when the activity coefficient is equal to 1, your activity can be related to concentration, और फिर हम activity की जगह पे लिख देते हैं concentration. In many of the books you will find this written as log of A of C to the power C. So it's like basically the activity of C into activity of D upon activity of A into activity of B. Now this activity is something which is directly proportional to the concentration. When the coefficient is like 1, we take the activity to be equal to the concentration only. Okay, many other factors that decide. Now the spontaneity of your cell reaction to occur. See, we know delta G is a factor and it has to be negative. So if I relate delta G as minus NF E cell, then I can say that my reaction will be spontaneous only if E cell is positive. So for any of my cell reactions to occur, my E cell should always be positive. ठीक है, क्योंकि तभी मेरा delta G negative होगा. Another reaction that relates your E cell to K is your delta G. If you remember, I must have given these formulae last year also. Delta G is equal to minus NF E cell. It is also equal to minus 2.303 RT log Kc or RT minus RT ln Kc. This is delta G, this is E cell. And if you generally have to talk about just an E naught cell, whether the reaction will be spontaneous, then you substitute the value of E naught cell there. That depends upon the question which is asked. Okay, some very simple formulae which are there. So electrochemistry is all about knowing these formulae and substituting their values. It's one of the easiest chapters that you can actually take up in chemistry. So delta G is equal to minus 2.303 RT log Kc. Delta G is equal to minus NF E cell. अगर इन दोनों को हम relate करेंगे तो we can get a relationship between E cell and Kc also. That can be what? You can have E cell to be equal to minus can get cancelled. You can have 2.303 RT upon NF log of Kc. Right? In that case, your reaction will be in equilibrium and there are chances that your E naught cell may also be equal to 0 for all you know. So वो सब चीज़ें देखनी पड़ेंगी. ये वाला ऐसे डॉट भी बना होता है वो, that's in the standard, that's हाँ ऐसे, that's the standard representation of G at standard conditions of temperature and pressure. and sometimes for molar quantities also. So the convention is generally that. जब उसका definition नीचे पढ़ोगे ना तो it must be that your Gibbs, if it is like delta G naught is equal to, so that only represents either your standard change, or for molar entities sometimes it is used as a dash sign or a not sign, that depends. Okay, some very simple formulae. All the formulae that we've done till now is one, E naught cell. E naught cell is equal to E cathode minus E anode, E right minus E left. Nernst equation is E cell is equal to E naught cell minus RT by NF 2.303 log of anode by cathode, or I mean if you know the cell reaction, or if you are able to write down the cell reaction, then it can be simply QC, right? So this way you can just write it down. Another expression which is like given here is, and you can also write this as some expressions that you can just note down. I am just giving you formulae. We will take up certain questions based on this. Delta G is equal to delta G naught plus RT ln Q. RT ln Q. Delta G is equal to delta G naught plus RT ln Q. And you know at equilibrium this delta G will be equal to 0. So at equilibrium delta G naught, now here naught means that I am talking about equilibrium, delta G naught is equal to minus RT ln of K equilibrium. So E naught cell that I have just written, I am writing it again, can also be written as 2.303 by NF RT log of K equilibrium. Delta G will be 0 at equilibrium, so delta G naught will be equal to minus RT ln of Q becomes equal to K equilibrium then, so hence the formula. And this also means that your E cell will also be equal to 0. The total E cell, because what is your E cell? The formula I am writing for the Nernst equation again, E cell is equal to E naught cell minus, अच्छा अगर अब चलो रूम टेम्परेचर की बात करते हैं, अगर मैं इसको रूम टेम्परेचर पे ले लूँ, इफ आई टेक दिस पर्टिकुलर एंटिटी एट रूम टेम्परेचर, then I know my 2.303 is a constant, R 8.314 is a constant, temperature 298 Kelvin if I take the room temperature. Number of electrons will depend upon my system, whatever I am taking, into Faradays is 96500. So then in that case this entire thing turns out to be equal to 0.059 upon N. So 912 in fact. So you can just note it down. So that will then become equal to 0.059 upon N RT log of QC. This is what we had written initially. So what happens at equilibrium? At equilibrium my delta G is equal to 0. I know my delta G, how is it related to my E cell? That is equal to minus NF E cell. So if my delta G is 0, then E cell also becomes 0. If E cell becomes equal to 0, then E naught cell becomes equal to 0.059 upon N. Yahi wali cheez. At equilibrium this will be obtained from here also. So at equilibrium E naught cell is equal to 0.059 upon N RT log of K equilibrium. Oh, 0.059 upon N log K equilibrium. Sorry. Because RT upon F is what we have calculated as into 2.303 as 0.059. Okay, let's, okay, what is activity is the question. I am saying that normally you used to write, जो ये reaction coefficient है, reaction coefficient is written as, for any reaction AA प्लस BB गिविंग CC प्लस DD, इसका रिएक्शन कोएफिशिएंट हम कैसे लिखते हैं, कॉन्सेंट्रेशन ऑफ द products upon the concentration of the reactants, right? That is the product of the concentrations of the products upon concentration of the reactants. So here QC can also be written as activity of the products, product of the activity of the products, each raised to the power of their respective stoichiometric coefficients upon activity of the reactants, each raised to the power of their respective stoichiometric coefficients. Now here I am saying that the activity is directly proportional to concentration of any substance. Say activity of A is directly proportional. तो इसका मतलब I will be putting some proportionality constant into A. This proportionality constant and under certain conditions of pressure and temperature can be found in this found to be unity. तो उस केस में activity can be replaced by concentration. So activity is some term which is directly proportional to concentration and can be related to it according to that. So you do not have to go into the depth because generally activities are not what is given to you in the questions. You are provided only with concentrations. Please make the correction. This 2.303 RT by F is 0.059. I had written RT by mistake on the board. So please, I am very fond of RT because that's my initial. So you have, now remember that E cell, the general Nernst equation is E cell is equal to E naught cell minus 0.059 upon N into log of QC. Now you can concentrate on the first question, I think. Just check up. Please look onto the screen here. Now here, read the question. You are given the standard reduction potential for Fe2 plus oblique Fe, Fe2 plus Fe and Sn2 plus Sn electrodes. Calculate the cell reaction. Calculate the cell reaction. You can easily calculate it. There is hardly anything that is to be done in it. The standard EMF, you have to calculate the standard EMF for the cell reaction. So in this case, what will you do? You know that E is equal to E naught of the reduced form. In this case, the reduced one is Fe minus E naught of the oxidized form, that is Sn. So that will be simply minus 0.44 plus minus of 0.14. So that will be equal to minus 0.30 volts. Alright. Now if I ask you, this is very simple. पर अब हम इस केस में, हाँ, सो E कैथोड माइनस E एनोड, ये सब एक बार रिवाइज भी करा दूंगी अभी पहले इस क्वेश्चन में, नहीं तो कंफ्यूज हो जाओगे बिकॉज इसमें उल्टा है. यहाँ पे एक चीज देखो कि यहाँ पे वी डिड इट अकॉर्डिंग टू द सेल रिएक्शन. ठीक है, सेल रिएक्शन के अकॉर्डिंग व्हाट वी हैव इज योर Fe2 plus is getting reduced to Fe, so that becomes our cathode straight away, and Sn is becoming Sn2 plus, so that means this becomes our anode because whatever is getting oxidized. We know that E naught cell without any bias, E naught cell will be equal to E cathode minus E anode, or E of the reduced form minus E of the oxidized form. So now E of the reduced form is nothing but minus 0.44, minus of 0.14 will actually give you the answer as minus 0.30 volts. Ideally speaking, we generally look for a positive E, and you know the reason for that. We generally want a positive E. Why? Because only if your E is positive, then only the reaction will be spontaneous. Otherwise, the kind of cell that we talk of, very good. The answer has come as minus 0.30 from the other center, which means everyone can solve it. So these are very simple questions in which do not get biased by the plus and minus sign. Minus sign का मतलब है that the reaction now is non-spontaneous. That means there will be no cell reaction occurring. तो वैसे सेल का कोई काम नहीं होता क्योंकि हमें तो स्पॉन्टेनियस रिएक्शन चाहिए. तो स्पॉन्टेनिटी के लिए अब मैं एक चीज़ यहीं पे बता देती हूँ, प्लीज़ याद रखना. स्पॉन्टेनिटी के लिए याद रखना, अब इसमें से एक -0.44 था. नाउ आई एम ऑफ द क्वेश्चन. आंसर टू द क्वेश्चन वाज वेरी सिंपल. अब मेरे पास एक -0.44 था, एक -0.14. मुझे इन दोनों से सेल बनाना है. ठीक है, आई वांट, अब ये इलेक्ट्रोड पोटेंशियल गिवन है, इलेक्ट्रोड पोटेंशियल इज गिवन, ऑलराइट. एंड जनरली जो इलेक्ट्रोड पोटेंशियल्स गिवन होते हैं, दे आर द रिडक्शन पोटेंशियल्स. रिडक्शन पोटेंशियल का मतलब है ये इस रिएक्शन का पोटेंशियल गिवन है. Mn प्लस गिविंग Mn प्लस n इलेक्ट्रॉन्स इज गिविंग m. ये जो इलेक्ट्रोड पोटेंशियल की वैल्यूज होती हैं, दे आर एक्चुअली रिडक्शन पोटेंशियल्स. दैट कैन ऑल्सो बी रिटन एज, जैसे दिस इज एक्चुअली द वैल्यू ऑफ m n, एक तो m n plus becoming m. So this is also represented like this, which means that this is the reduction potential. अब look up, ताकि ये पूरे चैप्टर में है ही सिर्फ एक ही चीज, बाकी सब चीजें are easy to understand. Lower the reduction potential, higher is the oxidizing power, self oxidizing power. मतलब जितना कम हमारा रिडक्शन पोटेंशियल होगा, उतना वो खुद को ऑक्सीडाइज कर सकता है. खुद को ऑक्सीडाइज मतलब दिस कैन ऑक्सीडाइज बेटर. एंड जो ज्यादा ऑक्सीडाइज करेगा, दैट मीन्स इट इज गिविंग इलेक्ट्रॉन्स, दैट मीन्स दैट शुड आइडियली एक्ट एज एनोड. या तो ऐसे याद कर लो, लोअर द रिडक्शन पोटेंशियल, दैट इज दैट हायर द ऑक्सीडाइजिंग पावर, सो इट विल एक्ट एज एनोड. एंड द अदर विल एक्ट एज, जिसका ज्यादा है इलेक्ट्रोड पोटेंशियल, ज्यादा इन टर्म्स ऑफ वैल्यूज. So this is -0.44, which is lower. So lower the reduction potential, greater is the self oxidizing power. Oxidizing power means वो electrons देगा, और electrons कहाँ पे देते हैं? Where do you have loss of electrons? That is at anode. That means your anode will be the one with the lower reduction potential value. Then the cell will function nicely. So and then if you check, then your E cell will turn out to be, E naught cell will turn out to be positive. Why? Because E cathode will be -0.14 minus of 0.44. So this will be -0.14 plus 0.44, which will be equal to plus 0.30. बात समझ में आई? तो ये चीज अपार्ट फ्रॉम द क्वेश्चन. अब क्वेश्चन देखते टाइम ये मत सोचना कि हो ये तो माइनस आ रहा है तो दैट मीन्स इट इज नॉट पॉसिबल, बिकॉज इन द क्वेश्चन यू हैव टू कैलकुलेट व्हाट इज गिवन अकॉर्डिंग टू द लॉजिकल सेंस. उसमें तो क्लियरली दे भी रखा है दैट Fe2+ इज गोइंग टू Fe एंड Sn इज बिकमिंग Sn2+. सो वहां से मेक आउट करो, ऑक्सीडेशन जहां हो रहा है दैट इज आर एनोड, रिडक्शन जहां हो रहा है दैट इज आर कैथोड. हाँ, तो फिर आपके सेल पे है. कई बार आई टेल यू, सेल बना रहे हो, मान लो आज नहीं, समवेयर डाउन द आई मीन 3-4 years डाउन द लाइन, इफ यू आर डूइंग सम रिसर्च, आपका सेल वर्क नहीं कर रहा, सिंपली क्या करो, इलेक्ट्रोड्स एक्सचेंज कर दो, एनोड को कैथोड बना दो, कैथोड को एनोड बना दो, तो देयर इज अ चांस दैट द सेल रिएक्शन विल अकर, बिकॉज द मोमेंट यू चेंज योर एनोड टू कैथोड एंड कैथोड टू एनोड, क्या डिफरेंस होगा? सिर्फ नेगेटिव पॉजिटिव का ही तो डिफरेंस है. And if you have your E cell to be positive. So remember that in your NCERT you given a table with very many values. You have a big table with lots and lots of values. Generally you are not expected to remember those values at all. ठीक है? The electrode potential of hydrogen is taken to be a standard one, which is taken as 0. So when you talk about standard hydrogen electrode, ठीक है, ये मैं अभी बाद में बताती, पर अभी अगर बात उठी है तो लेट्स टॉक. लोअर द रिडक्शन पोटेंशियल, और रिडक्शन पोटेंशियल का मतलब है N पॉजिटिव इज बिकमिंग M. लोअर द रिडक्शन पोटेंशियल, ग्रेटर विल बी द ऑक्सीडाइजिंग पावर एंड दैट शुड बी एक्टिंग एज एनोड. ठीक है, एंड द अदर वट एवर इज देयर विल एक्ट एज कैथोड. नाउ रिमेंबर दैट दिस विल बी जस्ट माइनस ऑफ E naught M of Mn+. अगर आपको क्वेश्चन में m गोइंग टू m, if you given the oxidation potential, this is known as the, if this is the reduction potential, this is the difference, सिर्फ एक साइन का होता है. So if you are given the oxidation potential in your questions, very rarely you just have to put a minus sign and it will become reduction potential, whatever value. So that is how the two are related. Then एक चीज याद रखना, standard hydrogen electrode means She, that is always 0. Standard hydrogen electrode is always taken as 0. Alright, so that doesn't mean She is 0. Getting the point? But if you talk about He, there is no bias at all. He means hydrogen electrode which is not taken under standard hydrogen standard conditions, that is negative. So if She is 0, he is negative. There is nothing to laugh at, this is chemistry. Okay. So what you have is standard hydrogen electrode is generally taken as 0 and hydrogen electrode is negative, and values for any of the reduction potentials need not be remembered. Okay, let's come on to the next question. The hydrogen electrode is dipped in a solution of pH is equal to 3 at 25 degrees Celsius. The potential of the cell would be, you are given the potential of the cell would be what you have to tell. Now you should be knowing the relationship for that. Remember that E is equal to, in this question, E naught minus 0.059 upon N into log of, now log of, see the activity of this is generally taken as unity of hydrogen gas or any solid metal atom is taken as unity. So that will be 1 upon the concentration of H plus, and you are given the pH as 3. You know what is minus log of H plus ions? That is, minus log of H plus ion is your pH. So you can always relate it to pH also. So that will be equal to, and what is the standard hydrogen electrode? It's given at 25 degrees Celsius. Iska matlab standard conditions. So the E naught cell, this SHE is 0, standard hydrogen electrode potential is 0, plus 0.059 upon how many electrons? 1 pH will give you the E. Just check up the minus sign, is it right? Minus log of H plus, you will have a minus sign here. You will have a minus sign because that's what I suddenly checked that the answer is actually C here. The answer is minus 0.177. Okay? So easy. This question was simple. And the general relationship, इसको अलग से formula note कर लो, that E cell is equal to E naught cell plus 0.059 upon N pH. Minus 0.059 into pH. So you can directly relate it to pH then. Clear? Look at the next question then. The answer to the question is now minus 0.177. वो तो multiply करके देख लोगे. I hope your answers are like pretty quick. The answering power is like pretty quick. Now here, the potential of the cell, concentrate on the question only. The potential of the cell containing 2 hydrogen electrodes are represented. Generally, whenever you have an hydrogen electrode, you talk about the platinum rods which are dipped in. So, is represented below, and you have to talk about the potential of this cell. What is the potential of the cell? The potential of the cell containing 2 hydrogen electrodes, you have to just talk about. So, in this case again E naught cell will be 0 and you will have now the concentrations of the right and the left. Concentration of cathode upon anode. So here I am generally writing the E cell to be equal to E naught cell is 0, so that can be minus of 0.059 upon N log of concentration of one to the other, so that is C2 upon C1. So that is taken as, E cell is taken as, you have 0.059 upon 1 log concentration of C2 is the right hand side, that's cathode, that is log of 10 to the power minus, oh I have put the same concentration, please correct it, this concentration is 10 to the power minus 4, this is 10 to the power minus 4, so that is minus 10 to the power minus 4 upon 10 to the power minus 6, and then you can calculate the answer correctly. Done. Can we move on? If the methodology is understood, can we move on to the next part? Here, if the temperature is generally not given, you can take it to be 298 Kelvin. Otherwise, it should be mentioned in the question. Let's move on to the next question. Okay. If the standard electrode potential of Cu2 plus and Cu2 plus Cu electrode, that is the reduction potential of the cell is given to you, E cell is provided to you, what is the electrode potential of 0.01 molar concentration of Cu2 plus? So, that means you are asked, given the reaction Cu2 plus 2 electrons is giving you Cu, and you are provided with the E cell will be equal to E naught cell minus 0.5912 upon N log of, I have told you if you can write down the reaction, then it's like an easy way out. If you can write down the reaction in this case will be what? Log of the concentration of products upon the concentration of the reactant. So this will be 1 upon concentration of Cu2 plus. Now here you are given the E naught cell value. What is the E naught cell value that is provided to you in the question itself? It is 0.34. So that is 0.34 minus of 0.591 upon what? 5912 or 59 I had taken upon 2, and that would be log of 0.01, because the concentration is also given to you, that is log 100, that is 10 to the power 2, so that is 2 into 1. So the answer is 0.281 volts. That can, the rest is like the working part, addition, subtraction, multiplication and division. I know all of you all can do it superbly. उसमें गड़बड़ करोगे तो फिर फायदा नहीं है केमिस्ट्री पढ़ने का. तो इसीलिए now we have this question. Again I repeat the question once again. We can look on to the question once. If the standard electrode potential of Cu2 plus Cu is given to you, that means E naught cell is given to you. What is the electrode potential of this concentration of the cell? The best way out for any such question is that you write down the reaction. Once the reaction is written, what do you have to do? Simply just put in the formula so that there is no confusion of cathode, anode. यहाँ पे तो confuse हो जाओगे नहीं तो. So, and you write down the equation and then just get the answer. Alright, let's move on to the next question then. Electrode potential for the cell is given to you. Electrode potential of the cell Zn Zn2 plus, Solbridge Cu2 plus, Cu is given to you is 1.10. So now you just have to tell what is the equilibrium constant of the reaction. Look into the question carefully. You know that E naught cell is equal to 0.059 upon N log of K. So therefore you can easily get log K from here, which is 1.1 into 2 divided by 0.059, because is the reaction given to you for the cell reaction. Let me just write down the reaction in this case. You all can write down the reaction yourself also. Zinc plus Cu2 plus is in equilibrium to give you Cu plus Zn2 plus. That is what the question is also showing, that your zinc is getting oxidized and copper is getting reduced. So here you can easily have 1.1 into 2 upon this, which is roughly equal to 37.2881. You will have to use the anti-log table for all those of you, or it's like simply log is, this is easy. Log k is 37, which means that k should be equal to 10 to the power 37 because this is log to the base 10. We have directly taken it as E naught cell, that means E cell is provided to you as, no, we have taken 1.1. Then here you can actually take it as, you know, E cell is equal to E naught cell. Take it E cell. Because we are not talking about take. Why should there be a minus sign? Here, please take down that this reaction is given at equilibrium. So for equilibrium, the E naught cell, we are talking about, remember at equilibrium, what is the reaction? I understand your discrepancy. E cell is equal to E naught cell minus blah blah blah. Alright, you have the Nernst equation like that. E cell is equal to 0. So that is why we are talking about E naught cell to be equal to positive of this. And E naught cell is given as 1.1. So 1.1 into 2 upon 0.059 ठीक तो है? You did not understand. Whenever the reaction, please understand this. This is like a simple question. Question तो समझ में आ गया. Whenever we are talking of a reaction to be in equilibrium, तो delta G is 0. If delta G is 0, which is equal to minus NF E cell, so E cell will also be equal to 0. And if E cell is 0, then E naught cell will be equal to plus of 0.59 upon N log of K. Simple. Got it there? In the end also you had it out. Here, everyone has solved this question. Easy. Electro में है कुछ difficult. I mean, you just have to substitute the values and get the answer. Direct questions, whatever is like to be understood, I'll talk about it very shortly. Okay, just one more question. Done with this question, can we take it off? The answer is like, now the next question. The standard EMF for the cell reaction, you are given the cell reaction and you have to find out the equilibrium constant, the same formula. You have to find out the equilibrium constant. So equilibrium नाम आते ही E cell is 0 and E naught cell is equal to plus 0.059 upon N log of K. K equilibrium, Kc, whatever you are calling it. ठीक है? So that can easily be worked out. So इसके अंदर तो direct substitution है, कुछ और करना ही नहीं है. You just have to remember that E naught cell is equal to E naught cell is equal to 0.059 upon N log of K. Can easily work it out. So you are provided with what? You are provided with, please excuse the typo errors, EMF, it is not EMF. So it is EMF of the cell reaction is given. Alright. Is there any data missing here? 0.36 is given. I thought the 0.36 is not there. So इसका मतलब 0.36 is given to you. 0.059. What is the number of change in the number of electrons? From +1 oxidation state it is going to +2 oxidation state. So 1 electron change. Cu2 plus देखते ही n should not be put equal to 2. वो 2 वाला आंसर भी इसी में ही होगा. So please take a note of it that here your Cu plus is actually getting converted to 2 plus. So just correct it accordingly. So here what you will have is 0.36 is equal to into log K, and then your log K is coming out to be equal to 6.091, alright, and or 914, and K is equal to, see, you do not have to check out any anti-log table for this. So simply k is equal to 10 to the power 6 is what you can straight away make out. So you do not have to get an exact answer. Exact निकालोगे तो वो यही वाला होगा. तो इसके अंदर if you have all the powers different, so just look into the correct option, and that is how. That is why you need a practice of the questions. Let me tell you, 3 of the options are totally redundant, जो किसी काम की ही नहीं होती. So you get some idea of the answer, and then you can easily make out which of them would be the best suited answer. So you know it is 10 to the power 6, so clearly D is the right answer. Alright, then now let me just talk back about some concepts. So are you all familiar with the formulae that we have just come across? Go through the formulae as I am rubbing the board. Then इतना ही टाइम लगना चाहिए फॉर्मूले रिवाइज करने के लिए. You have electrolytic cells, electrochemical cells, उसमें कोई डाउट नहीं है. सिंपल एक सिंपल सा फॉर्मूला है, E naught cell and your E cell. The rest of the delta G is something that you have done in thermodynamics already. Delta G is minus NF E cell, and that can all be related to the rest of the things in the world. Okay. Now there are certain parameters that you have. Now something which is known as resistance. You all must have done it in physics. Resistance is the obstruction to the flow of electrons. Or electrons ऐसे flow कर रहे हैं तो current will be flowing in the opposite direction. So resistance is some obstruction to the flow of current or flow of electrons, which is directly proportional to L by A. It is directly proportional to L by A, where now when you write it down as this becomes equal to rho L by A. Length, and this is the area of cross section that you generally talk about of your electrodes. Resistance, and this is your resistivity. This is your resistance, this is the constant of proportionality known as resistivity. L by A is generally known as your, what is your cell constant? L by A. That is your cell constant. So just giving you an explanation for that. So it is known as specific resistance. Remember that this is your resistance, this is resistivity or specific resistance. Please remember these names very categorically because you get these names highlighted. So this is resistivity or specific resistance. Now you can also define your resistivity as resistivity is equal to numerically equal to the resistance of a conductor of 1 centimeter length and having an area of cross section equal to 1 centimeter square. Because when you have this as unit, this is a unit area, then in that case R is equal to rho. This is like a general way of defining things, that your resistivity is equal to the resistance, which is resistance offered by a conductor of length 1 centimeter, and it has the area of cross section as 1 centimeter square. So then in that case that is there. Now the reciprocal of resistance is your conductance. Here we are talking just about the resistance. The reciprocal of resistance is your conductance, and that is your 1 upon R. 1 upon R, take the resistance of the, take the reciprocal of the rest of the right hand side term also. This is 1 upon rho, and this is equal to 1 upon L by A. I am just writing it like that, or A by L. एक ही बात है, L by A, 1 upon L by A is A by L. So I am just writing it like that. Now this is your conductance 1 by R, which is represented by a G. What do I see? So this is G. G is equal to, now 1 upon this resistivity is known as specific conductance or conductivity, which is represented by a symbol of kappa. I am not that good at drawing it, but you understand that's kappa. Kappa, kappa is one and the same thing, and that is upon cell constant. In case of cell constant, what is that will depend upon the kind of conductivity cell that you are provided with it. जैसे आपको जब भी एक conductivity cell मिलता है तो उस conductivity cell में always you have the cell constant mentioned on it, which is the ratio L of L by A, which is very important to for any kind of conductance to be understood. So that depends upon the conductor itself कि conductor का length और area of cross section कैसा है. It can be 1, it can be 1.01 also, it can be 1.5 depending upon the make. The best is when we take it as unity ताकि कोई discrepancy ही नहीं रहे. It is the area of the cross section in the sense that if you are talking about an electrode which has a make in such a way that you are talking about the length and the area of cross section is that of the entire conductor as a whole. Now it is to be looked on whether they consider only the bases or they consider it in totality. Yes. Alright. Now conductance therefore is equal to specific conductance or conductivity upon cell constant. So generally we do talk of conductivity a lot. So the formula, it's good to remember the formula of kappa, that is conductivity as conductance into cell constant, which is L by A. This you can remember. Alright, the units. Let us talk about the units. What will be the units of cell constant? It is centimeter upon centimeter square. So centimeter inverse or length inverse. L by A, तो cell constant की units याद रहेंगी. It is centimeter inverse. Now, if I talk about units of resistance, it's ohm. Resistance. Ohm. So it is ohm. So now here when you are talking about conductance, so conductance will be ohm inverse. कुछ ohm inverse था क्योंकि आप conductance के बारे में बात करते हो. Generally we do not talk of resistance. So this is now ohm inverse. Alright. Cell constant is centimeter inverse. So your kappa, which is your specific conductance, will be ohm inverse centimeter inverse. ठीक है? Units में there should be no confusion at all. I am not talking about the units of resistivity because generally they are not that important from this particular point, but you can make it out for yourself. I repeat, units of resistance ohm, units of cell constant length inverse. So units of conductance will be ohm inverse and conductance. Specific, so the units of conductance, which is just the reciprocal of resistance, will be ohm inverse, and for specific conductance it will be ohm inverse centimeter inverse. You all know how to write down ohm, right? Alright, so then that is why sometimes your ohm inverse is also written as this, that's your inverse, and it is also written as MHO. Just the reverse for your conductance. ठीक है? Now, so how will you define conductivity? Conductivity will be equal, specific conductivity or specific conductance will be equal to the conductance of the solution when it is in contact with a conductivity cell of cell constant unit of a unit cell constant, or cell constant of 1 centimeter inverse. That could have been put. Now there is another term, all these formulae are done. The most important formula from chemistry, electrochemistry point of view is kappa is equal to G into cell constant. Please remember, kappa has a name called conductivity or it is called the specific conductance. उसमें confuse नहीं होना है, ठीक है? And specific conductance, and G is your simple conductance. Then there is another term which we generally use in electrochemistry in conductance of solution, and that is known as molar conductivity. That is molar conductivity, and it is defined as conducting powers of all ions produced by dissolving 1 mole of a substance in solution. I repeat, molar conductivity is defined as the conducting power, इसका ना समझ के इसको याद करना, conducting power of all ions produced by dissolving, all ions produced by dissolving 1 mole, because I am talking about molar conductivity, so it is 1 mole of an electrolyte in solution, of an electrolyte in solution. I repeat, molar conductivity, इसको ध्यान से देखो, molar conductivity is conducting power of all ions. इसका मतलब जब मैं एक मोल ऑफ सब्सटेंस लेती हूँ and then I dissolve it in say any amount of solution, any volume of my solution, then that will be actually the conducting power of all ions produced by dissolving one mole. एक मोल को डिसॉल्व करने से कितने आयंस बने in solution is what is going to define my molar conductivity. That means molar conductivity can be directly proportional to the volume of the solution also. अगर डेफिनेशन समझ पा रहे हो तो जितना ज़्यादा मेरा वॉल्यूम होगा उतनी ज़्यादा मोलर कंडक्टिविटी होगी, बिकॉज दैट इज द कंडक्टिंग पावर्स ऑफ ऑल द आयंस व्हिच आर प्रोड्यूस्ड इन अ सॉल्यूशन ऑफ सर्टेन वॉल्यूम. तो वॉल्यूम अगर ज़्यादा होगा तो माई आयंस वुड स्प्रेड मोर इजीली, उनको घूमने के लिए ज़्यादा जगह मिल जाएगी एंड द कंडक्टिंग पावर विल इंक्रीज. ये चीज़ समझ में आई कि दोबारा बताऊं? अभी तक हमने क्या करा? कंडक्टेंस. G is 1/R. R is resistance or the obstruction to the flow of electrons. उसका reciprocal is your conductance. ठीक है. Now if I talk about conductance, then let's talk about conductance which is directly proportional to my cell constant. So it becomes my conductance is inversely. Now I am talking about, हमने अभी देखा कि my G is conductance which is equal to kappa upon cell constant. So let me just put it directly here so that there is no confusion in what I am saying. So when I am talking about conductance, conductance is mainly due to the ions. अब जितने ज़्यादा ions उतनी ज़्यादा conductance, क्योंकि conductance is just because of the ions. ये चीज़ समझ में आ गई? So that means my specific conductance will depend upon the number of ions. So जितने ज़्यादा number of ions उतने ज़्यादा मेरा concentration और उतनी ज़्यादा मेरी specific conductance. Hence specific conductance, because we generally talk of specific conductance is equal to conductance into cell constant. So I can say that my specific conductance kappa will increase with increase in concentration. ये चीज समझ में आ गई? रेजिस्टेंस क्या होती है? रेजिस्टेंस इज द ऑब्स्ट्रक्शन टू द फ्लो ऑफ इलेक्ट्रॉन्स. उसका उल्टा जो है दैट इज कंडक्टेंस. कंडक्टेंस विल डिपेंड अपॉन द नंबर ऑफ आयंस. अब जितने ज्यादा आयंस होंगे उतनी ज्यादा कंडक्टेंस होगी और उतनी ही ज्यादा स्पेसिफिक कंडक्टेंस होगी, बिकॉज स्पेसिफिक कंडक्टेंस इज डायरेक्टली रिलेटेड. So with increase in concentration, the specific conductance will increase due to the availability of ions in solution. Is that thing clear? Now if I am talking about molar conductivity, this is simple conductivity. नाम में confuse नहीं होना. Kappa is simple conductivity or specific conductance. That will depend upon the concentration, as जितनी ज़्यादा concentration उतने ज़्यादा ions and greater will be the conductance with concentration. Molar conductivity is the conducting powers of all ions which are produced by dissolving 1 mole of an electrolyte in solution. Now if I give you say little amount of the solution, alright, and you dissolve 1 mole, it will be highly concentrated, but the volume that is available, that मतलब जितना solution है वो तो कम है, तो उस वजह से all the ions will not be able to show the conducting power to a great extent, because it is the conducting power of all ions. So all ions will not show the conducting power to a great extent. Now when I put more say water in it or I dilute it, जब मैंने इसको डाइल्यूट करा तो कॉन्सेंट्रेशन का मतलब कॉन्सेंट्रेशन कम हो गई. अगर कॉन्सेंट्रेशन कम हो गई तो उस केस में नाउ द आयंस विल बी फ्रीली फ्लोइंग इन दैट वॉल्यूम, सो द कंडक्टिंग पावर ऑफ आयंस विल इंक्रीज. सो दैट मीन्स व्हेन द कॉन्सेंट्रेशन रिड्यूसेस in case of molar conductivity, molar conductivity will increase. So understand the difference. Conductivity will increase on increasing concentration, but molar conductivity will decrease with increase in concentration. समझ आया? दोबारा बताती हूँ. Conductivity is now here. Now conductivity is simply depending upon the number of ions. See, it will be dependent on volume. Now if you increase the concentration, now the number of ions will remain the same. तो उनका conductance उस case में will not get affected to the extent, because here if concentration increases, ठीक है, concentration increases means that the number of ions are increasing. If number of ions are increasing, then this implies your kappa will increase. ठीक है, but अब इस case में if concentration increases, same चीज़ ही लिख रही हूँ, if concentration increases, that means the volume for the same volume, इधर भी same volume की बात कर रहे हैं, उधर भी same volume की बात कर रहे हैं. इधर अगर same volume में हम concentration increase करते हैं तो the number of ions will increase, so kappa will increase. Now here concentration, if it increases for the same volume, the number of ions will increase, but the conducting power of all the ions will not be recorded. It will only be recorded only when your volume increases. And volume कब increase होगा? When your concentration decreases, क्योंकि volume जब increase करेंगे तो concentration automatically कम हो जाएगी. How is concentration increases? If I talk about something to, इसका मतलब concentration जब decrease करेगी, when concentration decreases, इसका क्या मतलब है constant? That means dilution will increase. So if I am saying concentration decreases, मतलब मैंने dilution बढ़ा दिया है, volume बढ़ा दिया है. So now the conducting powers of all the ions which are produced by dissolving 1 mole will be more, because then the flow of ions will be more. क्योंकि it is like dependent on the speed of the ions also. Let me be very frank. The speed with which your ions are moving also decides its conducting power. ठीक है? So dilution increases, the lambda m will increase. अच्छा, from this definition that I have talked about, it implies that my lambda m is inversely proportional to concentration. It is inversely proportional to concentration, and what I get is the formula is generally taken as kappa upon C, or when C is taken in general concentration terms, it's also written as 1000 kappa upon C. Let me just confirm it also for you. If you taking the n as a normality, you can just write the lambda equivalence. Molar conductivity will be upon C लिख दो, because you will write normality when it is equivalent conductivity. Yes. If you increase the volume, then in that case your conductance will remain the same, because the number of ions remain the same. And if you increase the volume, that means you are decreasing the concentration. And if your concentration, see, this is, understand this, this is the conductivity for a particular cell constant. That means the conductivity around the area of around it will be around the conductor of 1 centimeter length and 1 centimeter square area of cross section. तो अगर 1 area of cross section, if you check it around 1 centimeter inwards, then the number of ions now which are available will become less, क्योंकि अगर आप concentration बढ़ा रहे हो, अगर आप concentration को, sorry, if you're decreasing the concentration, then the number of ions available for 1 area of cross section or 1 centimeter length will decrease, and if that decreases, your conductivity goes down. But here it is unaffected, because it is depending on the conducting power of all the ions which are available to a volume of solution. When we सर यस यस इट गेट्स अफेक्टेड बिकॉज अगर आपने वॉल्यूम इंक्रीज करा मतलब कॉन्सेंट्रेशन कम करी मतलब नंबर ऑफ आयंस व्हिच आर अवेलेबल फॉर अ पर्टिकुलर एरिया डिक्रीजेस इफ दैट डिक्रीजेस देन योर कप्पा विल आल्सो डिक्रीज. सब कंफ्यूज हो गए या सो गए? कंडक्टिविटी इज this just generally depends on concentration. So concentration is 1 mole, 2 mole, 1 molar, 2 molar, 3 molar, 4 molar. So depending upon your concentration, your kappa will increase accordingly. And the relationship between kappa and molar conductivity is lambda m is equal to 1000 kappa upon C. So you see from here, if you take C to the other side, so then kappa is again directly proportional to C. But if you see C at the denominator, which is inversely proportional to lambda m, if C increases, lambda m will decrease. अब समझ आता है तो ठीक है, नहीं तो direct formula for your entrance examination is lambda is equal to 1000 kappa upon C, and for kappa is G into cell constant. ये सबको याद हो गया, मेरा purpose solve हो गया. But at least try and understand कि ऐसा क्यों होता है कि जब हम कंसंट्रेशन बढ़ाते हैं तो स्पेसिफिक कंडक्टिविटी बढ़ती है. जब कंसंट्रेशन व्हेन वी इंक्रीज द कंसंट्रेशन कंडक्टिविटी और स्पेसिफिक कंडक्टेंस इंक्रीजेस बिकॉज ऑफ इंक्रीज इन द नंबर ऑफ आयंस. मेन रीजन क्या है? इंक्रीज इन द नंबर ऑफ आयंस. बट हियर लैम्डा एम that is molar conductivity decreases on increase in concentration, and that is because it is inversely proportional to concentration. ये ज़्यादा maths ज़्यादा अच्छे से सम. So lambda m is inversely proportional to concentration. So if concentration increases, lambda m decreases. पर समझो क्यों? concentration कम कब होगी? जब हम dilute ज़्यादा कर देंगे. तो dilute अगर ज़्यादा करेंगे then the ions will be having more conducting power for a particular volume of solution, and so the lambda m increases. आ तो गया समझ? फिर क्यों ऐसे बोल? और yes, but the number of ions are dominant in this case. यहाँ पे lambda m, that is why, do you ever see me writing definitions on the board? I have written this especially because lambda m, that is the molar or the equivalent conductivity, molar or equivalent conductivity is the conducting power of all the ions which are produced by dissolving 1 mole or 1 gram equivalent. Because अगर lambda equivalent होगा, equivalent conductivity, that will be 1 mole of an electrolyte in solution. उसको जब डिसॉल्व करेंगे तो उसकी कंडक्टिंग पावर विल इंक्रीज, एंड द नेक्स्ट लॉ दैट वी विल डू विल बी रिलेटेड टू दिस. अब समझ आया तो ठीक है, नहीं तो मैं थोड़ी देर बाद रिवाइज करूंगी. लेट योर माइंड फॉरगेट इट एंड देन आई विल रिवाइज इट अगेन. सो द फॉर्मूला अगेन, इलेक्ट्रोकेमिस्ट्री में यू हैव सर्टेन फॉर्मूले एंड न्यूमेरिकल्स बेस्ड ऑन इट. सो let me just look into it. What have we written now? Just two formulae that we done. One is for kappa, I am not writing it again and again. Kappa, whatever you prefer. So kappa is nothing but G into cell constant, and your lambda m is equal to 1000 kappa upon C, or lambda equivalent is equal to 1000 kappa upon N. N, normality. It does depend upon the degree of dissociation. Let's talk about it first before moving on, or do you want me to take up numerical? We'll just go through a numerical ones. Now again, the formulae are simple. You know lambda m is 1000 kappa upon C, and because अब inverse relationship है C से, तो ये तो याद रख सकते हो कि अगर मैं बोलूँ जैसे मेरा कॉन्सेंट्रेशन इंक्रीज होगा तो मेरा लैम्डा एम क्या होगा? लैम्डा एम क्या होगा? डिक्रीज होगा. तो अब ये वाला क्वेश्चन इज ऑलवेज आस्क्ड generally in your board examinations and is also important otherwise in the field of chemistry, because for those of you who continue chemistry in future will have to deal with this thing again. अब ये तो पता है ना, अब कॉन्सेंट्रेशन अगर इंक्रीज होगा तो लैम्डा एम हमारा डिक्रीज होगा. गुड. ऑलराइट, लुक इट टू द क्वेश्चन नाउ. द टू प्लैटिनम इलेक्ट्रोड्स, let's solve the question. This is the question. All right, the two platinum electrodes fitted into a fitted, please excuse the typing errors, fitted. All right, the two platinum electrodes fitted in a conductance cell are 1.5 centimeter apart. So you are given the L, that's the distance between the two electrodes, so that is 1.5 centimeter apart, while the cross sectional area of each electrode is 0.75 centimeter inverse. So now that thing is clear. L is the length between the two electrodes and area is cross section is your length into breadth of the electrode size. So you have cross sectional area of electrode, that is 0.7. What is the cell constant? Do you want me to do it? Cell constant is L by A. What is L? Some students are not doing it. That is length is 1.5 upon 0.75. Alright. That will be in centimeter inverse, so the answer is 2. Alright, next question. Lambda EQ is 1000 kappa upon N. C मतलब concentration accordingly ले लो. अगर molar conductivity है तो concentration will molarity. If it is equivalent conductivity, then the concentration will be in normality. बहुत easy topic है ना, so you getting time to talk. Now conductivity of 0.01 normal solution is given to you. What is conductivity? It is your kappa. ठीक है? So conductivity is given to you. Then you are given the conductivity is like given to you, concentration is given to you, the equivalent conductivity is to be told. So that is 1000 kappa upon N. So everything is provided to you in the question. I don't think you need to. So that is nothing but 1000 into kappa, that is 0.005 upon 0.01. You want me to do it?
No, ma'am.
So it is? नहीं. Let me just do it. It will be 0. First of all, formula will be 1000 kappa upon C. So you have 0.005 into 1000 upon 0.01. So decimal place तो यहीं से चला गया 3 zeros. So that will be 500. So 500 means option number A here. Units are not given. Ohm inverse, centimeter square, equivalent inverse, which is not written here. Because ohm inverse आया यहाँ से, you have ohm inverse, centimeter inverse इसका हो गया, kappa का, and concentration inverse will also be included here. That will be equivalent inverse. कोई शक? Okay, then next question. Now do it on your own. Okay, specific conductance of 0.1 molar sodium chloride. Sodium chloride solution is 1.06 into 10 to the power minus 2 ohm inverse centimeter inverse. You have to talk about its molar conductance. Molar conductance here means your molar conductivity only. That's like in error. Please make it out. Molar conductance here is your molar conductivity only, because you have lambda m to be equal to kappa, which is 1.06 into 10 to the power minus 2 into 1000 divided by, what is your molarity? 0.1. So that will be simply 1.06 into 10 to the power 2. Absolutely right. So it is option number A again. And the units will be ohm inverse, centimeter square, mole inverse. 2 ही आएगा. Alright, next question. So very simple questions. So vis-a-vis your formulae, and we were spending a lot of time in understanding, which is also very important to retain it for a long time. ठीक है, next question देखो. Molar conductivity of a solution is given as 1.26 into 10 to the power 2 ohm inverse centimeter square mole inverse. I repeat the question. Quiet. The molar conductivity is given to you now. So that means lambda m is given to you and the molarity is also given. You have to tell the specific conductivity. Specific conductivity means kappa. तो बताओ what is kappa? Molarity नहीं given. Molar conductivity of a solution is 1.26. Its molarity, take it as 0.01 molar. Take the molarity as 0.01 molar. So it will be your kappa will be equal to lambda m into molarity upon 1000. So that is 1.26 into 10 to the power 2 into 101 divided by 1000, which is 1.26 into 10 to the power units. So option B. Alright, just one more question and then we will proceed with the other thing. Alright, just note this question again. The specific conductance of a solution is 0.03568 ohm inverse centimeter inverse, and when placed in a cell, the conductance is given as 0.0268 ohm inverse. So you are given the conductance, that is conductance is G, you are given kappa, you have to tell the cell constant. इससे ज़्यादा तो simple question नहीं हो सकता. You have G, you have kappa, you have to tell the cell constant. So you know what is the relationship? Kappa is equal to cell constant into G, and cell constant therefore will be equal to kappa by C, kappa by G. So that the answer is जो अलग से लिखा हुआ है 1.331 centimeter inverse. That's simple. Your kappa upon G, kappa is given, G is given. I mean, this question should not take more than 5 seconds. I must have taken more time to speak than you took to calculate. Alright, next thing is now factors affecting the electrolytic conductance. When we talk about the electrolytic conductance, see electrolytic conductance. Now you know electrolytic conductors are what? Which have the flow of electricity due to flow of ions. So here we primarily talk of our lambda m or lambda equivalent only. That means we talk about the molar conductivity or equivalent conductivity only, which you now understand is equal to 1000 kappa upon C. Alright, and you know that as concentration increases, your lambda conductivity will decrease. Please ये चीज याद रखना. Specific conductance increases with increase in concentration. Molar conductivity decreases with increase in concentration. Reason, definition. जो reason है समझ के बोलना, ऐसे नहीं बोलो. So the reason is that when we are talking about, you can take it also as एक और तरीका है ना. I talked in terms of volume increase. You know that this is 1000 kappa upon C is the general formula. You know C is what? It is number of moles of number of moles of your substance upon volume in liters. So that means your lambda m will be directly proportional to volume. तो जितना ज़्यादा वॉल्यूम होगा उतनी ज़्यादा डाइल्यूशन मतलब और उतनी ज़्यादा हमारी मोलर कंडक्टिविटी. एक और तरीके से मैंने आई जस्ट हेल्ड माई नोज. So what you have is lambda m is inversely proportional to concentration is right. But also understand that as we increase the volume, that means as we decrease the concentration, my molar conductivity will increase. Alright. So here now understand what are the different types of electrolytes. ठीक है, ये मैं अभी बताती हूँ. उससे पहले factors on which your electrolytic conductance depends. First is the nature of electrolyte. Nature of electrolyte, whether your electrolyte is a weak or strong. Very good. Whether it is a strong electrolyte or it is a weak electrolyte. अब फर्क क्या होता है? Strong electrolyte को जैसे you will put it in water, it will get dissociated completely, totally. जैसे for example you have your HCl. Okay, my favorite NaCl. NaCl is a salt and I have told you that all salts are strong electrolytes. तो इसका मतलब the moment you put them in water, they will completely dissociate. So strong electrolyte का मतलब है there is no scope of any equilibrium. It will just not remain as HCl. The moment you put HCl in water or you put NaCl in water, so what will happen immediately? It will no longer remain as this. It will only be existent in the form of ions. So Na plus plus Cl minus, completely in ions. But what is the meaning of weak electrolytes? Weak electrolyte means that they will be incompletely dissociated. जैसे acetic acid is a weak acid. They will be incompletely dissociated into their respective ions, and the ions in this case will be CH3 COO minus plus H plus. मतलब कुछ फॉर्म हमारा डिसोसिएटेड है और जो ज़्यादा पार्ट है दैट इज अनडिसोसिएटेड. It is so adamant that it refuses to dissociate because the molecule in itself is so stable. So you have CH3COOH giving CH3COO minus plus H plus. Now it is seen from here that the behavior of these electrolytes, the molar conductivity of these electrolytes have a different behavior. If we make a plot of lambda n, that is molar conductivity versus the concentration, then in that case, you know, in both the cases of strong and weak electrolytes, the molar conductivity will decrease with increase in concentration. तो इसका मतलब इसका decrease, that means if I talk about NaCl, a strong electrolyte, then and I plot, एक concentration लेते हैं, उसकी molar conductivity नोट करते हैं, फिर एक और concentration बनाते हैं NaCl की, उसकी molar conductivity plot करते हैं. Then we make a further more concentrated solution of NaCl. Concentrated solution पता है ना कैसे बनाते हैं? It's like you are taking 1 spoon in 1 glass, that's a little concentrated. Now you are taking 2 spoons in 1 glass, more. But it is very, I mean, this should be done at 8th level that I explain in terms of spoon. You can actually weight and put it and then find out the concentration. Concentration निकालनी सबको आती है. Normality is number of gram equivalents upon volume in liters. Molarity is number of moles upon volume in liters. So all of you know. तो एक particular concentration बना के we record the equivalent or molar conductance, and we see that for a strong electrolyte it decreases like this. That is, the molar conductance decreases with increase in concentration, or I can say that the molar conductivity increases with dilution, क्योंकि इस तरफ को concentration is moving towards 0, because you increase the water level to a great extent such that the concentration remains only minimal, then it is considered to be infinite dilution. Infinite dilution का मतलब होता है जब when I increase the volume to such an extent that the concentration becomes negligible. Okay, so then in that case you can have you talk about infinite dilution when C approaches 0, when your C approaches this 0. Alright, so for weak electrolytes the behavior is like this. There is like a sharp decrease, that is in case of weak electrolytes like CH3COOH or any other weak electrolyte. Now how to explain the behavior? The explanation of the behavior actually comes directly from two equations. For the strong electrolytes, देखो ये strong electrolytes का behavior है that they decrease steadily. धीरे 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 डिक्रीज हो रहे हैं. बट फॉर वीक इलेक्ट्रोलाइट्स देयर इज अ स्टीप डिक्रीज. स्टीप डिक्रीज मतलब सडनली अभी हमारा एक कॉन्सेंट्रेशन पे ये वैल्यू था, दूसरी कॉन्सेंट्रेशन पे सडनली देयर इज अ डिक्रीज इन द वैल्यू. सो व्हेन वी ड्रॉ स्मूथ कर्व बाय जॉइनिंग द पॉइंट्स ये ऐसे बनता है. ऑलराइट, सो वी सी दैट देयर इज अ sharp decrease right at the beginning, but here there is a slow and steady decrease. The reason is, for strong electrolytes, the reason can be given by D by Huckel on Sager theory. D by Huckel, these are the names of the scientists, so don't get confused. On Sager theory. If you also do something like that, 10 years down the line, we'll learn a theory based on your names. Be positive. So we have D by Huckel on Sager theory, which clearly relates your lambda m as lambda m naught. In fact, it is a plus b to the power b root c. Shh. D by Huckel, I am not going into the depth of this theory because that is not what is more important. I am just explaining it to you that here strong electrolytes are completely dissociated. आपको पता है strong electrolytes are completely dissociated. If I increase the concentration, then in that case their molar conductivity will decrease only slowly because they are already in the completely dissociated form. या फिर ऐसे समझो, I give you 1 molar solution of NaCl. Now you are decreasing the concentration. That means आप इस तरफ को चल रहे हो, इधर. ठीक है. Now you are decreasing the concentration by adding water to it. When you add water to that solution, the number of ions still remain the same, Na plus and Cl minus, और उनकी conducting power भी उतनी की उतनी ही है. It will increase a little bit because that is the nature of your molar conductivity, that the conducting power will increase, but उतना drastic increase नहीं होता. This I am explaining it to you qualitatively. जैसे now you are adding water to it, it is already in the fully dissociated form. So what miraculous did you do? You have increased just the volume a little bit and decreased the concentration, so the conducting power increases only a little bit, a little more, a little more, a little more. So that is why there is only a gradual increase on dilution for molar conductivity of strong electrolytes. It is explained by D by Huckel on Sager theory, which states that the molar conductivity with increase in concentration will decrease according to a linear rule. Linear plot है ना? And you know linear equation is y is equal to mx plus c. So if this is your y, this is your x, as your x is increasing, the slope is a little negative and it will be a straight line with an intercept. समझ में आया? C नहीं लिख रही, वो concentration है इसलिए. Strong electrolytes. In case of strong electrolytes, it's a straight line only that I am showing. This is an experimentally obtained plot. But how do you explain it? Strong electrolytes are already completely dissociated into their ions. So on further dilution, the conducting power increases only slightly. It is explained by D by Huckel on Sager theory, which is this explanation that lambda m is equal to lambda naught minus b root c. Or in certain cases you will find actually that this is given as lambda m is equal to a plus b root c, a minus b root c, which means that if you increase the concentration, the slope will be a little negative. That is why it's decreasing according to a linear plot gradually. ये mathematical explanation हो गया. Qualitatively मैंने समझा दिया था क्योंकि fully dissociated है तो ज़्यादा फर्क नहीं पड़ता. Okay? Then for the weak electrolytes, we generally explain it using the Ostwald's dilution law. For weak electrolytes, the explanation is given by explanation of this graph. Because let me tell you, first things are obtained experimentally. जब graph एक मिल गया plot, उसको फिर explain करने के लिए you think of theories कि क्या चीज़ हो सकती है because of which the strong electrolytes are decreasing like this and weak electrolytes are decreasing. The lambda m is decreasing sharply and drastically with increase in concentration. That is explained using Ostwald's dilution law. That something similar you have done before also. Say if I have CH3COOH and you know it's a weak electrolyte, so it will be giving you CH3COO minus plus H plus. Say initially let the concentration of the weak acid be C, so then this will be 0 and 0 at the initial point. If alpha is the extent of the reaction, then this after some time will become C alpha, and C alpha will be reduced from this. So that will be C minus C alpha or C into 1 minus alpha. Now the equilibrium constant here, the equilibrium constant can be written as C square alpha square upon C into 1 minus alpha, that is equal to C alpha square upon 1 minus alpha. Now because it is a weak electrolyte, here in this case, because I say that this is a weak electrolyte means that the degree of dissociation, what is degree of dissociation? The extent of dissociation is very very low, क्योंकि it's a weak electrolyte. So I can consider my alpha if it is much less than 1. अगर मेरा extent of dissociation is very small, then I can write K equilibrium to be equal to C alpha square, and then the extent of dissociation will be equal to, where K is not kappa, please don't get confused. मेरा kappa और K same ही दिखता है. So K is equilibrium constant. So this implies that your extent of dissociation is inversely proportional to root C. And this is what we had plotted. Lambda m, अब इसको समझ लो, it's easier to understand it now. With increase in concentration, your degree of dissociation will decrease, and अगर degree of dissociation decrease हो गया तो number of ions कम होंगे, क्योंकि ions तो right hand side में थे. अगर number of ions कम होंगे तो lambda m will be less, molar conductivity will be less. समझ आया? So that is why the relationship goes like this. It is an inverse relationship. जितना ज़्यादा root C उतना कम lambda m, because the extent of dissociation is going to be very small. And if my C becomes very small, then in that case my degree of dissociation will be very high. And if it is going to be very high, then in that case I can say that for infinite dilutions my weak electrolyte will almost be completely dissociated. बात समझ आई? Thank you. I repeat it again. We are trying to explain and study the nature of the graph here in this case, that is molar conductivity with increase in concentration. One thing is absolutely clear to all of you all, that with dilution lambda m increases. That means with decrease in concentration our molar conductivity increases, because the conducting powers of all the ions is more. अब strong electrolytes के case में, which are completely dissociated, there is a gradual decrease, धीरे धीरे slow increase in lambda m with dilution. Whereas in case of weak electrolytes, there is a sharp increase in lambda m with dilution. That is based on Ostwald's dilution law. You have understood this, which you have already done. So from here we get a relationship that the extent of dissociation, कि कितने ions बन रहे हैं, will be inversely proportional to my concentration. मतलब जितनी कम concentration उतना ज़्यादा dissociation. Lesser the concentration, greater is the dissociation, and greater the dissociation means greater is the conducting power of the ions, greater will be the number of ions and greater will be their conducting power. So lambda m will be very high with increase in dilution. Now when the dilution is to the extent that you increase lots and lots of volume and the concentration also almost becomes zero, that is known as the time when you talk about infinite dilution. that is generally represented as this, molar conductivity at infinite dilution. और क्या हो रहा है molar conductivity का at infinite dilution? It's becoming very very high, which means that now this is now the dissociation is almost complete. इसका मतलब जो हमारा weak electrolyte था, that almost reaches complete dissociation or achieves complete dissociation at infinite dilution. This we get from this graph, but otherwise is given by Kohlrausch. Okay, that is Kohlrausch's law. We will talk about the Kohlrausch's law. It states that, yes, पर देखो स्ट्रॉन्ग इलेक्ट्रोलाइट्स के केस में, स्ट्रॉन्ग इलेक्ट्रोलाइट्स के केस में क्या होता है, इट इज ऑलरेडी इन द कंप्लीटेड डिसोसिएटेड फॉर्म, और वीक इलेक्ट्रोलाइट्स के केस में वो कम डिसोसिएटेड होता है व्हेन द कंसंट्रेशन इज हाई. व्हेन वी ऐड वाटर टू इट, नाउ देयर इज फ्रीली the ions are now will be having more conducting power. If ions move off here and there, then there will be more dissociation of the weak electrolyte. If there will be more dissociation, then the ions will be more conducting again. तो यही वाला phenomena चलता रहता है, and then you have हाँ, क्योंकि now the reaction is proceeding more and more to the right. ये वाला जो reaction था CH3COOH giving CH3CO minus plus H plus, जब ये वाले ions volume increase होने पर they will be freely moving here there, then the concentration around a particular molecule will decrease, तो वो more and more it will dissociate. So that is why with increase in dilution, that is volume of your solution, your lambda m increases drastically, and at infinite it is believed कि weak electrolyte का भी total जो lambda m है that is equal to the lambda m of individual ions, क्योंकि हम तब मानते हैं कि वीक इलेक्ट्रोलाइट भी टोटली डिसोसिएट हो गया. तो अगर इनफाइनाइट डाइल्यूशन की बात करते हैं तो लेट मी जस्ट एक्सप्लेन इट फर्स्ट यूजिंग एग्जांपल्स एंड देन आई स्टेट द कोलरॉशस लॉ. इट इज दैट अगर इनफाइनाइट डाइल्यूशन की बात करते हो तो दैट मीन्स लैम्डा एम इन्फिनिटी एट CH3 इन्फिनिटी पे जो CH3COOH है, वी बिलीव इट गेट्स ऑलमोस्ट कंप्लीटली डिसोसिएटेड. So here we have lambda m infinity of CH3COO minus plus lambda m infinity of H plus. This is at infinite dilution, and we can write this for strong electrolyte also. Strong electrolyte पहले भी totally dissociated था और infinite dilution पे भी totally dissociated ही रहेगा. तो there is no harm in writing this equation also for a strong electrolyte, that lambda m infinity of NaCl is equal to lambda m infinity of Na plus ions plus lambda m infinity of Cl minus ions. This we can make use of to find out the lambda m infinity or lambda m of those solutions for which it cannot be determined directly. Yes, that is what is your Kohlrausch's law that you just told me. Kohlrausch's law states that, you can just write it down also. I am talking about Kohlrausch's law. It states that the equivalent conductivity of any electrolyte at infinite dilution is equal to the sum of the equivalent conductivity of its ions and of its cations and anions. एप्लीकेबल, बट स्ट्रॉन्ग तो पहले भी इनफाइनाइट पे लो या नहीं लो, स्ट्रॉन्ग तो यही रहेगा चाहे इनफाइनाइट डाइल्यूशन पे ले रहे हो या नहीं ले रहे हो. टोटल कंडक्टिविटी ऑफ NaCl इज नथिंग बट Na प्लस का कंडक्टिविटी प्लस Cl माइनस का मोलर कंडक्टिविटी. बट फॉर वीक एसिड्स इट इज नॉट ट्रू एट अदर कॉन्सेंट्रेशंस. फॉर वीक एसिड्स दिस विल बी ट्रू ओनली एट infinite dilution. So that is why Kohlrausch's law states that at infinite dilution the total molar conductivity of any substance is equal to the independent molar conductivity of its constituent ions. And as given here in the notes that I am carrying, it is the equivalent conductivity of any electrolyte at infinite dilution. At infinite dilution, it is the sum of the equivalent conductivities of its cations and anions. For example, if you are writing lambda m for Ax By, it will be equal to x into lambda infinity for A y plus y of lambda m of B x minus. ये lambda m is, this is lambda m, this is lambda m naught is just the molar conductivity at naught. Sometimes in many of the books is referred to infinite dilution and sometimes it is C, तो that is at a particular concentration. तो वो कई बुक्स में infinity, कई बुक्स में not यूज़ करा हुआ है, depends upon the standard usage जो book author has used. But you can have certain more formulae that we can learn right here, right now. ये तो याद रखना that the total molar conductivity is equal to the molar conductivities of the independent ions at infinite dilution. And then there are more formulae also. Let's practice one question for this. See, Kohlrausch's law is mainly utilized for determining the lambda m infinity for weak electrolytes. क्योंकि strong का तो as it is total होता ही है. And then it is also used for determining the degree of ionization. It is also used for determining the degree of ionization. It is used for the ionization constant that we will see. Let's look into one of the numericals. See the equivalent conductance, look onto the screen here. The equivalent conductance of NaCl, HCl and C2H5COO Na is given to you. ठीक है? Normally what we have is when we write down the equation, अब हमें क्या चाहिए? We want the equivalent conductance of C2H5COOH. तो इसका straight away तरीका ये है कि you pick up the one which has maximum number of atoms. ठीक है, पूरा नहीं तो otherwise in schools you must have written complete equations and then you know you've done it. For here, for a quick calculation, what you can do is the equivalent conductance of this propionic acid is asked. So you have C2H5COOH here, इसका निकालना है. So that will be equal to C2H5COO Na का molar conductivity minus Na करना है. तो minus molar conductivity of NaCl. अब एक Cl माइनस ज़्यादा हो गया है तो Cl ऐड करना है. So plus lambda m of HCl. So clear cut the final expression will be lambda m of C2H5COH is equal to lambda m of C2H5CONa minus lambda m of NaCl plus lambda m of HCl. Anyways we needed an extra H here. तो उन सबको when you add it up you will easily get the answer. So do it directly. Otherwise जो normal protocol है that is written in another form. Okay, so here what you have is the amount of substance, here lambda m of C2H5COOH is what I am telling you can be written as lambda m of C2H5COO Na is given to you minus lambda m of NaCl plus lambda m of HCl. This is at infinite dilution, infinite dilution, infinite dilution and infinite dilution. And because we haven't elaborated any of the questions, let me just elaborate using this example. हमें निकालना है lambda m infinity of C2H5COOH. I can write down the reaction for C2H5COOH as this will be C2H5COO minus plus C2 plus H plus. Right? This is the equation that we are actually looking at. What is the answer? I hope you've done the correct calculation. 390.71. Right, okay. Now, because it's the only example that I've picked up for Kohlrausch's law, so let me just elaborate it once, although many of you understand it completely. हमसे पूछा है lambda m infinity for this acid. Alright, that is propionic acid. You have propanoic acid, sorry. propanoic acid, you have C2H5COOH, you know it will weakly dissociate into the propanoate ions plus your H plus. इसका हमने अगर लैम्डा इन्फिनिटी बताना है, सो दिस शुड बी इक्वल टू, हमारा नेट लैम्डा एम इन्फिनिटी शुड बी इक्वल टू lambda m infinity of this ion CO minus plus lambda m infinity of H plus. You can write this equation for each of the equations that we write. This is the wanted one. So this is the wanted one. And how did I arrive at this directly? I am just telling you that. So now what you have is you are given जो चीज़ें given है जिनका lambda infinity, उनकी equations you can quickly note down. This is this is a salt, क्योंकि base plus an acid forms a salt, and all salts are strong electrolytes, so it will get completely dissociated to form C2H5COO minus plus Na plus. So this is your equation number 1. The other equation that is given to you is that for, you are given the lambda m infinity for NaCl, that will be equal to Na plus plus Cl minus. Another equation will be that of HCl. HCl is going to give you H plus plus Cl minus. So this is your second equation and this is your third equation. So for each of them you can write down the lambda m infinity Coloroch's law. That will be lambda m infinity of this will be equal to lambda m infinity of this ion plus this ion according to Coloroch's law. When we add them in totality, according to this, क्योंकि 1 plus 2 करेंगे, क्योंकि 1 minus 2 करेंगे, because I want to get rid of this Na plus. मुझे क्या चाहिए अपनी स्टार इक्वेशन में, I want the C2H5COO minus plus I want NH plus. ठीक है, तो C2H5CO minus यहाँ से आ गया, Na को हटाना है तो माइनस सेकेंड इक्वेशन करते हैं. माइनस सेकेंड इक्वेशन मीन्स लैम्डा m infinity of NaCl, which is like Na will get cancelled then, and then प्लस Cl माइनस एक एक्स्ट्रा, अब मेरे पास माइनस Cl माइनस यहाँ आ गया, तो आई नीड अ प्लस Cl माइनस टू गेट रिड, बिकॉज आई डोंट वांट Cl माइनस. सो फॉर दैट आई विल ऐड द थर्ड इक्वेशन का लैम्डा इन्फिनिटी, दैट इज ऑफ HCl, सो दैट माई H प्लस गेट्स एडेड अप जो मुझे चाहिए, एंड माई Cl माइनस ऑल्सो गेट्स एडेड अप, सो दैट इट टेक्स केयर ऑफ द माइनस Cl माइनस आई गॉट बिफोर. ठीक है, एंड देन व्हेन यू डू द कैंसिलेशन यू फाइनली गेट योर स्टार इक्वेशन एंड द स्टार आंसर. That is 390.171. Okay, so Coloroch's law is as simple as that. Then we talk about the electrolysis. By and large, whenever we are talking about an electrolytic cell, what is happening inside an electrolytic cell is a phenomenon which is known as electrolysis. Okay, now in electrolysis, what we have is, in electrolysis, it is the phenomenon in which passage of current flows through an electrolyte and brings in chemical changes which are involved. Now electrolysis is a phenomenon in which the current flows through an electrolyte and brings about the chemical changes which are required. It involves two electrodes and an electrolyte. One electrode is known as cathode and the other electrode is known as anode. The solution, which actually is a bridge between the two, is generally if it is in the same container, called an electrolyte. The reaction at cathode will be that of the reduction reaction. The reaction at anode will be the oxidation reaction. Lower the reduction potential, higher will be the oxidizing power, and it will act as anode. Then only you will find that your E cell is always positive. E naught cell is always positive. E naught cell is positive means that the reaction will be spontaneous, and your cell will be spontaneous, or cell reaction will be spontaneous, because then delta G, which is equal to minus NF E cell, will be negative. याद हो गया या दोबारा सारा कराऊं? Right. No, then in that case there is a change in the sign conventions also at times, but generally the anode is taken where the oxidation occurs, and the oxidation will only occur wherever the reduction potential is low. तो वो वाली चीज़ तो follow होती है. फिर भी I haven't looked into very many examples, but this can be checked of what you are asking for. Okay, so now we can actually, before the class gets over, we can do the Faraday's laws also. so that whatever is required for your numericals and all, the formulae are taken care of. Faraday also gave two laws of electrolysis. You must be familiar with them. Have you done Faraday's laws? Very nice. So that makes work easier for me. Faraday's first law of electrolysis, let me just talk about. I just put the mathematical expression then. Faraday's laws of electrolysis. The first law states that the amount of substance, this is the first law, that the amount of substance deposited on an electrode is directly proportional to the charge, passed into the fused state or in aqueous solution of the electrolyte. The amount of substance which is deposited on the electrode is directly proportional to the charge. This is your first law. Faraday's law clearly states that the amount of substance W, amount matlab it's the mass, the amount of substance deposited on an electrode is directly proportional to the charge which is passed into the fused state or the charge which is passed into the electrolyte. What is your charge? That is equal to IT. The proportionality constant in this case is generally taken to be equal to Z. So W is equal to ZIT is your first law. Z is a proportionality constant. ठीक है, अगर मान लो मैंने सेम करंट पास करा है, मैंने दो इलेक्ट्रोड्स लिए हैं, ठीक है, if I have taken two electrodes, then if in electrodes in electrode 1 I pass some say 5 ampere current, मतलब जितना करंट मैं इसमें पास करी हूँ उतना ही दूसरे इलेक्ट्रोड में पास करी हूँ for the same time. So then in that case, say for electrode number 1, the reaction will be the amount of substance deposited will be equal to Z1, which depends upon of course the material, the nature of the substance, W1 into IT, because the current that I have passed and the time for which I have passed is the same. So charge मैंने same रखा है. Now I take another electrode and then in that case you know Z2 will be different and IT will remain the same. If I take the ratio of the two, then that will be W1 by W2 will just be equal to the ratio of the proportionality constant Z1 by Z2. This is somewhat related to our second law now. Faraday's second law states that by passing the same charge into two different electrolytes, the amount of substances deposited is directly proportional to their number of equivalents or equivalent weights. Is directly proportional to the number of equivalents, or please take a note that when Q is constant. All right.
Constant is different for different amount of masses. It changes.
Z1 will primarily depend upon the substance that you are talking about. So if it depends on the nature of the substance, like here in this case, if you are equating it to E, then in certain cases it can also be it is also found to be equivalent to the equivalent mass that remains constant throughout for a particular solute or the substance. Okay. So now here the second law states that you have W1 by therefore W2 is equal to E1 by E2. By passing the same charge into two different electrolytes, the amount of substance which is deposited is directly proportional to the equivalent weight of the substance, or it is directly proportional to the gram equivalents of the substance, to the number of equivalents. And remember that when I pass 1 coulomb charge, 1 coulomb means when I pass 1 coulomb of charge, the amount of substance deposited will be equal to Z grams. Now here Z, the proportionality constant, may be representing your equivalent weighted times, or it is generally dependent on the nature of the substance that you are talking about which is to be deposited. So if this Z is equal to the amount of substance deposited when 1 coulomb of charge is passed through the solution, that's Z is directly proportional to W, which in turn is proportional to E. So that is how the relationship goes. Otherwise Z is nothing but it is the amount of substance which is deposited on your electrode for a unit charge. Alright. Then you can take a question on it. I think simple expression, simple formula. Just take a one last question for the day. You want more questions? I'll pass the assignment. Good girls. Next question. 2.5 Faradays of electricity is passed through a solution. Start doing the question. Read the question carefully. Focus on the question. 2.5 Faradays of electricity is passed through a solution of copper sulfate. The number of gram or gram equivalents of copper deposited on the cathode will be. Read the question carefully. 1 Faraday deposits 1 gram equivalent of copper. Please make a note of it. 1 Faradays. This is a very simple question. Very good. So the answer will be 2.5. See, 1 Faraday will be depositing 1 gram of copper sulfate. Okay, 1 Faraday. No, make a note of it also. Make a note of it that 1 Faraday of electricity, so 1 Faraday of electricity deposits 1 gram equivalent. Deposits 1 gram equivalent of a substance. So therefore 2.5 Faradays will deposit 2.5 grams. So इस question में तो कुछ करने को ही नहीं था, so we can take up one more question. So one more question. All right. When a copper cup plate is with silver, क्या है question? When a copper cup is plated with silver by passing 965 coulombs of current, coulombs of electricity, sorry, then in that case copper cup plate is plated by silver. So that means silver is deposited on the copper plate. It is plated with silver. So silver, that means is deposited. So go back to the question again. Question. Okay, so 96500 coulomb deposits, you know, that deposits 1 gram atom, which is equal to, you should be knowing the, I am giving you the atomic weight of silver, that is 107.87 grams. Please make a note in the question itself. The atomic weight is 107.87 grams. So take a note of the question again. So that means 1 Faraday, 96500 coulomb deposits 1 gram atom, which is 107.87 grams of silver. ठीक है? If that is the case, that 965 coulombs का कितना? That will be 107.85 divided by 96500 into 965. So that gets cancelled. You have a upon 100 factor. So the answer is C, that is 1.0787. ठीक है? Repeating this question again, बहुत simple question है. When a copper cup plate is deposited with silver, that means silver got deposited on it. Silver का कोई हमने solution लिया, उस पे डाला, तो हमारा silver solution में ionic form में होगा. Ag plus electrons becomes Ag, is only to make you understand. So silver gets deposited on our copper cup plate. So 96,500 coulombs generally deposit 1 gram atom. That means equivalent to 1 mole of silver. So that is equal to 107.87. If 96500 coulombs is equivalent to 107.87 grams of silver, so then how much will be the amount of silver deposited for 965 coulombs? That will be then the unitary method that is given on the board, that not given on the board, 107.87 divided by 96500 into 965, and the answer becomes 1.0787 grams. Alright. Then I think more questions can be practiced, but let us quickly revise as to what we've done, because we've already done quite a bit of electrochemistry today. Just a revision for the last 2 minutes. In electrochemistry, electrical energy, chemical energy, just these two energies. You read the names and the chapter gets done. Because the main formulae that we have here is E cell, E naught cell, delta G, E naught cell in terms of K, and you have Faraday's laws, you have lambda m, you have kappa and G. Bas, yahi formula kya? This could have been done in half an hour's time also. And next time when we start with our class, I'll revise these formulae for you in 2 minutes, just as I will be doing it now. E naught cell is equal to E right minus E left, E cathode minus E anode. Okay, now when we are talking about cathode and anode, one more very important base of electrochemistry. Lower the reduction potential, higher is the oxidizing power, and it will act as anode generally. But when it is given in the question, then do not impose your mind. Okay, so E naught cell done. Then the Nernst equation is very important, which states that E cell is equal to E naught cell minus 0.059 upon N log concentration of anode upon cathode. That can be checked. You can write the reaction completely, and then according to the reaction can write down the product concentration upon the reactant concentration, and you can do it. Then what is the value of She? She is 0. He is alright. Then after E cell and E naught cell, we've covered up the formula for delta G is equal to minus NF E cell. Delta G in terms of equilibrium constant is minus NF, that is equal to minus 2.303 RT log K, and then you can relate E naught and K also. Alright, one reaction that you did was also in terms of pH. Okay? So pH wala can also be related to it. Then you have to remember the oxidation reduction Haas cells. Then we started talking about resistance ka formula everyone knows, R is equal to rho L by A. The reciprocal of it gives you an important relationship for conductance. Specific conductance is equal to conductance into cell constant. Specific conductance is also known as conductivity. Specific conductance increases with increase in concentration. Alright. Then we come on to lambda m. Lambda m is equal to 1000 kappa upon C. As concentration increases, lambda m decreases. For a weak electrolyte, the decrease is sharp, sudden. For a strong electrolyte, it's gradual. You know the reason. For the first one comes from d by Huckel-on-Sager's linear equation. Then for the next one, it comes from Ostwald's dilution law. Metallic conductance decreases with temperature. You all know the reason. Because it starts vibrating, so there is resistance to the flow of ions or charge, so therefore metallic conductance decreases with temperature. But specific conductance increases with increase in temperature. Please make a note of it. Specific or molar conductance that increases with increase in temperature, because as temperature increases, the ion movement also increases, so because of that it increases. But in case of metallic conductors, it decreases. Clear to everyone? And then last but not least, we talked about the Faraday's law. First law is W is equal to ZIT. Second law is W1 upon W2 is equal to E1 by E2. Alright, revise till here, be thorough, all the best for your test and do well. Thank you. Metallic conductors की conductivity decreases